Okay, welcome back, students. We're going to cover section 1.3 now. Let's get into that. Okay, so we have trigonometric functions. Okay, trigonometric functions. Let x, y be a point on the terminal side of an angle theta in standard position. The distance from the point to the origin. Distance from the point to the origin is r. Okay, and that's equal to x squared plus y squared. So if we look at what x and y are here, okay, this is the y direction, and then this is the x direction. And so this creates a right triangle, and by the Pythagorean theorem, we know that x squared plus y squared is equal to r squared. Well, if we square root both sides, we get r is equal to the square root of x squared plus y squared. We would normally have a plus or minus there, but we don't need it in this case because in a geometric figure, distance is always positive. And so we're going to get rid of that plus or minus, actually. Let's just do it this way. There we go. Okay, we have our 6 trig functions. Sine of theta is y over r. Okay, so the y value over r. The cosine is the x value over r. So think sine y and cosine x. Tangent is y over x. Cosecant is the reciprocal of sine, which is r over y. Secant is the reciprocal of cosine, which is r over x. And cotangent is the reciprocal of tangent, which is x over y. Okay, so let's use our newfound knowledge to do an example here. Example 10, the terminal side of an angle in standard position passes through 0.8, -6. Find the values of the 6 trig functions. The first thing we need to find out is what's r. What's the radius here? Okay, if we look at this, this is going to be 8 and -6, and so the angle that we're looking at is this angle here. And so if we were to draw a right triangle, oops. Okay, we would get y, our x value is going to be 8, our y value is going to be -6, and so if I do r equals the square root of x squared, which is 8 squared plus -6 squared, y squared, that's going to be equal to the square root of 100, which is 10. So we know that r is equal to 10 here. So now that we have x, y, and r, we can find out what all the 6 trig functions are. We have the sine of theta. Sine of theta is equal to y over r. So that's y over r, which is -6 over 10, which reduces to -3 over 5. Cosine of theta is equal to x over r. And so x is 8 over 10. And so that reduces to 4/5. We've got 3/5, 4/5. Okay. Tangent of theta is equal to y over x, which is going to be -6 over 8, which is equal to -3/4. Okay, so that's tangent of theta. Okay, cosecant of theta is just the reciprocal of sine, and so that's going to be -3/5 flipped upside down, which is going to be -5/3. Secant of theta is the reciprocal of cosine, which is just going to be 5/4. And the cotangent of theta is equal to the reciprocal of tangent, which is -4/3. Okay, let's move to number 11. Find the 6 trigonometric function values of an angle in standard position if the terminal side theta is defined by x plus 2y = 0. Okay, so this is the equation of a line. Okay, x plus 2y = 0. I could solve this for y, and I get y equals, okay, well, I'm going to go 2y is equal to, move the x to the other side, and we get x, right? And so I'm going to go divide by 2 now, and we get, or sorry, this is -x. So y is equal to -1/2 x. Okay. And so this is the slope of the line with a y-intercept of 0. Okay, so we want to find, okay, this is -1/2 x. So if I start at 0, 0, slope is y over x. Okay, it's the change in y over the change in x. Okay, and so that slope is very, very synonymous to tangent. So the change in y over the change in x. So that's -1, okay, over 2. So -1 over 2. So -1 and then over 2. Okay, and so we get our line. And if we were to go up 1 over -2, we would get another point. And so we get this line here. Okay, and I want to create an R. I want to create a radius. I want to know, okay, well, what's, if y is -1 and x is 2, then how am I going to create my theta? Well, theta is always the angle with respect to the x-axis. Zoom in here. And so this is angle theta. Okay, I could, oops. Okay. And so we want to know what's R here. And I'm just going to use these 2 points that are on the line. I'm going to use 2 points that I found on the line to calculate R. And this is going to be R right there. Okay, we already know what x and y are going to be. Well, y is -1 and x is 2. So this is equal to y and this is equal to x. I just have to figure out what R is. Okay, so R is equal to the square root of x squared plus y squared. So that's going to be equal to the square root of 2 squared plus -1 squared. So this equals 4 plus 1. And that just equals radical 5. So R is radical 5. So we want to know, well, what's the sign? Okay, what's the sign of theta? Remember, that was the y over R. So y over R. So this is going to be -1 over radical 5. And I can rationalize the denominator here if I want to, multiplying both top and bottom by radical 5. And that equals negative radical 5 over radical 25, which is just 5. So radical 25, and so this becomes negative radical 5 over 5. Okay, that's the sine of theta. Okay, cosine of theta is going to be the x over r. So this is going to be 2 over radical 5, and we can do that same trick of radical 5 over radical 5, and that just gives us 2 radical 5 over 5. Okay, the tangent of theta Well, that was just y over x, which was synonymous to our slope. And so that just equals -1/2. Okay. So that's that guy. That's that guy. Okay, so now I just need to find what's the reciprocals of these. And so the cosecant of theta is a reciprocal of sine. And I'm going to go to this one right here before I rationalize the denominator, because I don't want to have to rationalize the denominator again. This if I flip this upside down, this becomes -1 over radical 5. But if I flip it, that's the original. If I flip it, it becomes radical 5 over -1, which is just negative radical 5. So I don't have to rationalize it. I just keep it with the radical in the denominator, and then the radical becomes the numerator. Okay, so let's do secant now. Secant of theta is going to be equal to the reciprocal of 2 over radical 5. Well, the reciprocal of 2 over radical 5 is just radical 5 over 2. Okay. So this just becomes radical 5 over 2. And that is rationalized. So that's the answer there. Okay, tangent of theta is going to be equal to, cotangent of theta is going to be equal to -1 over 2, but excuse me. Okay, -1 over 2, but because that's what tangent is, but flipped upside down. So this becomes -2 over 1, which is just -2. Maybe I'll put that in blue. -2 over 1, which is just -2. And so we get our 6 trig functions. I'll erase this. Erases everything. Okay, those are our answers to our 6 trig functions. Okay. Note, we can use any point on the terminal side to find the 6 trigonometric functions. Note, when finding the trigonometric function values of quadrant angles, it is convenient to use the point 1 unit from the origin, or r equals 1. Okay, so find the 6 trigonometric function values for each angle. So we want the angle of 360. Well, 360 is the same. Okay, that is congruent to 0 degrees. If I were to just subtract 360, I would get 0. Okay, and so this is at 0 degrees. Well, what is 0 degrees? Well, that's just out here. It's just the x-axis. And they're saying it's convenient to let r equal 1. So we're going to let r equal 1. And we're going to say that this is 1 unit. Okay, so what's interesting is that r here is also x, and they're both 1, okay, because it's in the x direction, and y is 0. Okay, so let's use this to get our 6 trig functions. Sine of theta is equal to y over r, which is going to be 0 over 1, which is 0. The cosine of theta is equal to x over r, which is 1 over 1, which is 1. Okay, the tangent of theta is going to be y over x, which is 0 over 1, which is 0. Okay, and then the cosecant of theta is equal to r over y, which is the reciprocal of sine, so that's r over y, which is 1 over 0, but I cannot divide by 0, so we say that this is undefined. Okay, the secant of theta is just the reciprocal of 1. So reciprocal of cosine. Okay. Remember, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Reciprocal of cosine is r over x, which is just 1 over 1 again, which is 1. And the cotangent of theta is the reciprocal of tangent, which is just x over y, which is going to be 1 over 0, which is undefined again. Okay. Okay. Part B, an angle theta in standard position with terminal side passing through 0, -5. So at 0, -5, I'm 0 in the x direction, but -5 in the y direction. Okay, and that's an angle of 270 degrees. Okay, so theta is equal to 270 degrees. So we want to know, well, what's the sine here? Okay, and they're saying if I were to use just going from the origin to the point, okay, to find out what r is, okay, r is the distance from the origin to the point, and the point is at 0, -5. The distance between 0, 0 and 0, -5 is just 5. So r is equal to 5 there. But y, the distance, the y value is -5, and the x value is 0. So let's find the 6 trigonometric functions here. So the sine of theta is equal to y over r, which is -5 over 0. Sorry, -5 over 5, which is -1. Okay, so that's the sine. Okay, the cosine of theta is going to be equal to x over r, which is 0 over 5, which is 0. The tangent of theta is going to be y over x, which is -5 over 0. And again, we can't divide by 0, so this is undefined. I'm going to abbreviate that here so I don't have to write out the whole thing. Okay, undefined. The cosecant of theta, which is just the reciprocal of sine, is going to be r over y, which is equal to 5 over -5, which is again -1. The secant of theta is equal to r over x, which is going to be equal to 5 over 0, which is undefined. And the cotangent of theta is equal to x over y, which is 0 over -5, which is 0. And those are the 6 trig functions there. Okay, so that's 1.3, and I'll see you guys in the next section.